Okay guys, so today we're going to be talking about mixture problems. And I just want to talk about mixtures. So sometimes, like, you could be at home and you're making lemonade. And you take some water and some lemonade mix and you mix them together. That's a mixture. You've mixed two things together. I don't know, sometimes I make trail mix for my kids. I take almonds and raisins and I mix them together. That is what we're going to be doing when we're doing mixture problems. We're going to be mixing two quantities or putting together two quantities. We also could be mixing distances or average speeds together. Like you drive a car and you drive your car for a certain speed for a little bit of a distance and then for a little bit of time, sorry. And then you'd go at a faster speed because the speed limit changes. So anytime we're going to be mixing quantities together, we can think of them as mixture problems, okay? All right, so when dealing with mixture problems, each item added will have two components to it. So you're going to have the amount of each item. For example, you might have 2 pounds of raisins, or you might have 200 milliliters of a solution. And the other component is related to the item, such as the price of the raisins, or the amount of raisins you're adding, or the percent of acid that's in the mixture or in the solution, okay? So each item will have two components. Then the two items being mixed will be added together, because when you mix two items together, you add them together to make a whole quantity. All right, now there's many ways, you can search the web all day, and there's many ways that teachers teach you how to do mixture problems. Some use charts, some use pictures, some just use verbal models. I'm actually going to talk to you about a verbal model, but I'm going to show you two ways to do it. And I'm going to feel comfortable if you use either one. Okay, either one will work for me. All right, so I want us to think about a verbal model. So my verbal model is that we have this mix one, something that we're going to mix. And then we're going to have another mix of something. And when we mix those two things together, we're going to get a total mix. But remember, I told you that each mix is going to have two things. And those two things we are going to have to multiply together, okay? Now let me show you my example. All right, so method one I'm going to use for this first one. I'm going to use a picture. I'm going to draw a picture. But a health food store sells a mixture of raisins and roasted nuts. Raisins will sell for $3.50 a kilogram, and nuts sell for $4.75 a kilogram. So already I can see that raisins, we're talking about raisins, are $3.50 and nuts are $4.75. It says how many kilograms of each should be mixed in order to make 20 kilograms of the snack that will be worth $4 a kilogram. All right, so I look at the question to get my let statement. It says how many kilograms of each. So I'm going to let R equal the kilograms of raisins. I'm going to use raisins, okay? Sorry about my smartboard today, guys. It's not working so great, and it's doing funky things, so my colors keep changing. All right, so how do I do this drawing a picture? Well, in my mind, what I like to think of is bowls. Bowls of raisins and nuts, okay? So I'm going to make two bowls. I've got my raisins, and I've got my nuts. And I'm going to mix them together to get this new mix, and it'll be a mix of the two of them. So here's my mix one, mix two equals my total mix. All right, within each of them, we've got to have an amount, and in this case, a price. So I always put the amount at the bottom of the bowl. So for raisins, so I'm going to put raisins here so we label, okay? Here's my raisins, here's my nuts, and I know I ran out of room here, this is my total. Okay. All right, so how much raisins do I have? Well, I don't know because that was my unknown. So I'm going to label this R. So that's how many raisins I have. All right, I know that I want to make a total of 20. So I know that this mix needs to be a total of 20 kilograms. All right, so if I have a total of 20, and I know that this is R, then the amount of nuts would be 20 minus R. All right, so that's the amount of nuts or raisins I'm mixing together. Now, each of them has a value, so that's that second component. All right, so raisins cost $3.50, so I'm going to put that on the side, $3.50. The nuts cost 475. Let me move this plus sign so I have a little bit more room here. So I'm going to put 475 here on the outside. And we want the new mix to be worth $4. So I'm going to put $4 there. All right, so with each raisin or each mixture, I need to multiply those values, okay? The amount of raisins by the price. So I'm going to multiply R times 350, and I'm going to put that inside. I'll change colors for you. So that's 350R, okay? I'm going to multiply the next two, and I'm going to get 4.75 times the quantity, 20 minus R. And then I'm going to multiply 4 times 20, so 4 times 20, which gives me 80, okay? All right, so now I'm set and ready to write my equation. So my mix one that makes up both components would be 350R plus my second mix, which would be 475 times 20 minus R equals 4 times 20, which gives me 80. All right, so now it's a nice, easy equation, a linear equation that I know how to solve. All right, so first I'm going to distribute my 475. Great place to be using that calculator and keep it handy. So 475 times 20 works out to be 95. I'm going to distribute the 475 and get then negative 475R equals 80. Okay? Then I'm going to combine the like terms. So I'm going to combine 350R and negative 475R, and I'm going to get negative $1.25R. I'm also going to subtract 95 to both sides. So I isolated my variable, and I get negative 15. And then I'm going to divide both sides by negative 1.25. So then R is equal to 12. Okay? Now I go back. So R was 12, and it asked me how many kilograms of each. R was the kilograms of raisins. So we have 12 kilograms of raisins. And then 20 minus 12, which is 8, we have 8 kilograms of nuts. And if you think about it, this is very similar to the dimes and quarters questions, because we always took the number of dimes and quarters we had and then the value of each of them, and then we added them up to equal the total. Same type of problem, okay? All right, let's look at method 2. Method 2, same idea, but instead of using a picture, we're using a chart. All right, my charts are actually slightly different from the ones in the text. I flip them around. I like it to have solution 1, solution 2, and mixed solution going across the top. They put this over here. I'm okay with any method you choose, but I'm going to be using one of these two methods. All right, so we have an auto mechanic, has 300 mLs of battery acid solution that is 60% acid. He must add water to this solution to dilute it so that it is only 45% acid. How much water should he add? Okay, so how much water should he add? So I'm going to let X equal the amount of water. Okay, so now we have to think about these solutions. Remember, every solution has two components. The amount of the solution and that other component. And in this case, it's acid because it's an acid solution. So we have the amount of solution, which is the milliliters or the kilograms, and then a percent of acid. So I'm going to put percent acid. Okay? All right, so let's look at the first solution. He's got the first solution, he's got this battery acid, he's got 300 mLs of it. So I'm going to put 300. And it is 60% acid. Now, 60%, I'm not going to write as 60%, I'm going to write that as a decimal, so 0.60. Okay? All right, the second solution, it says how much. The second solution is water, because he's adding the water. And we don't know how much water he's adding, so that was our variable, that's our X. So now we got to think with our brain a little bit, the common sense part. What's the percent of acid in water? Well, water has no acid, so it would be 0%. Okay? All right. So now, going across, remember it's first solution plus second solution equals the mixed solution, the final solution. All right, so we have 300 plus X would be how much we have in our final solution. we've got 0.60 plus 0 is going to be the amount of, I'm sorry, he must add water to the solution so that it is 45%. So we want our mixed solution to have a content of 45% acid, okay? All right, so now here's the part that's a little bit different with the charts. You have to multiply your two components. So I'm going to multiply 300 times 0.60. And that's what I gave you for that last box. So times 0.60 plus x times 0 is going to give me 0. I'm just going to put it there so we see it. And then we've got our final solution, our mixed solution. It's going to be equal, so 0.45 times 300 plus x. So again, we're mixing your two solutions to get a final solution. Each solution has two components which you multiply together, and then you write your final equation. If you do the chart like this, your final equation will actually be your bottom line, okay? All right, so let's work with that. We've got 300 times 0.60 plus 0 equals 0.45 times 300 plus x. 300 times 0.60 is 180 plus 0 I can get rid of. 0.45 times 300 is 135 plus 0.45x. All right, so now we isolate the variable. I subtract 135. Oh, and looky there, we get 45. So 45 equals 0.45x. We divide by 0.45. And then x would be equal to 100. Okay, so we go back to our original equation, okay? And x was the amount of water we should add. The question is in milliliters, so we're going to add 100 milliliters of water, okay? And that's going to actually give me a solution that is 400 milliliters of 45% acid. So what did we do, guys? We just diluted it. We added some water to the mix to dilute the acid so it wasn't so strong, okay? All right, so those are the two methods. I tend to like the picture versus the chart, but I'll do both, okay? So I just wanted you to see both. If you feel the need to watch these again, please do so, and we'll talk about them, and we'll be practicing them for several days, okay? Have a great night.